Cool. So today we're going to cover a few things. First, I want us to go back to the lab that we worked on last week. And I want to, if you recall, for those of you who were here and for those of you who weren't, oh, I should start this in a new session so I don't undo all those models I just compiled. Because I don't want to overwrite all that hard work I just did with running that sampler and everything. I'm going to create a new RStudio window, just a new session of R, so I can have two sessions going at the same time, one that has some work that I wanted to have ready to roll and one that is going to be new stuff. Okay, but if you recall last time, what we did was we took some data from Fatal Encounters, and I'll just kind of work us to sequentially through everything that we covered. Um, so we have this data set. This is the lab reshaping.r file that's in the labs folder, and the data file is in the root directory of the course repo. So if you have fetched or pulled, you should have everything. So I'm just going to Command Option B to run everything underneath that line. That's my favorite shortcut in RStudio, is either Control or Command Option B or Control Alt B on a PC to just run everything above my cursor. So if I put my cursor somewhere, it's just going to rerun the script above it. It's great. So here's Fatal Encounters, right? And or let's glimpse it. This is what that data. Okay, or no, there's a lot here. Anyway, we have individual level data on police involved deaths, right? And remember, this data has some, funky file names, funky variable names. So we're going to rename a few of the variables we're going to work with and select those, right? So now when I do head FE, I get that. So those are the variables that we focused on last time. Our goal here was to build out a data set that we could use to build out models to estimate differences in risk of being killed by police by race and ethnicity, right?
I'm sorry, I don't mean to interrupt, but maybe other people have this problem. I'm not getting the lab reshaping R when I get pool.
Okay.
Yeah, same.
Okay. That's because it wasn't pushed. My bad. Sorry about that. Should have pushed that last week and didn't. So it's in there now. Give it maybe 1 or 2 minutes and it will be in there. But yeah, you could try running git fetch now or git pull now and see if you get it. It usually updates within 10 to 20 seconds. Sorry about that. Thank you for the catch. Okay, the magic of the internet. Okay, so anyway, once we're there, and the Fatal Encounters data, I believe, is up. Let me just confirm that. No, sorry. I posted it on a Dropbox link last time.
I have it now. I don't know if other people do.
You may have downloaded it last week. Okay. That is also going up now. That's a bigger file, so that may take a second to get up there. I think it's like a 20 megabyte file. So, okay, so you should be able to pull that down in a moment. Did I bind that onto the pop? I did bind that onto the pop data. So all the things I should have done last week, we're going to do now. Okay. So there's those three files. That should be all you need for today. The homework solutions everyone has access to, right? Yeah. Okay. Cool. Sorry about that. Okay. So. Okay. Thanks, Felipe. There we go. Now, right. So we can go basically here to get the tables by race. And remember, we saw some typos and some categories that we weren't going to be able to use because they don't match onto the census's population data. So first, we want to just look at this to get counts by race ethnicity. And remember, we could either use table or group by summarize to get similar crosstabs. There's the count of cases by race ethnicity. We have some typos in here. And so we used case when to correct all those typos, right? And now if I run this again, I get a reduced set of categories. Notice with gender, we also had some issues. So we recoded gender. And now if I run that table again, we fixed those and we've made one missing. Okay, we're going to remove non-numerics from age. Now I'm going to pause here because this is where we're going to pick up. Last time we do table FE $age, we have a lot of stuff going on here, right? We have, sorry, I have to scroll because your lovely faces are on my console. Okay, so boop-a-doo. We have a lot of stuff in here. So what our goal would be to use like the as numeric function to just turn like, you know, um, 24 into the number 24. But the problem is that there's information here encoded as a string, right? So there's information here encoded with letters that doesn't map onto um, exactly what we're after. Now, what we could do is we could go through manually and case when transform this in the same way that we did with the race and sex variables. But I want to show you a slightly different way to tackle this problem. So we're going to use a few different tools to program our way out of this problem. Okay, so sorry, let me arrange my windows in a way where I can see everything going on. Okay, there we go. There we go. Okay, so what we're going to do is we're going to take these and try and organize it and try and basically make our life a little easier. So what we want to do is use a few tools from the string R package, and those should load in as part of tidyverse. So to confirm that it's loaded in, I know that str_sub is a string R function, and that is coming up in the help file. So it's loaded. I'm good. So if you do library tidyverse, you get a bunch of packages, including string R, dplyr, ggplot, tidyr, readr, a bunch of stuff. So stringr is one that we're going to use that we haven't really used before. So what we want to do is we are going to do a case when, but let's take like an easy problem here, right? I see a lot of these that say our goal is to produce a variable that's numeric for number of years of life a person has, right? So how old they were when they died. We're going to basically say, so that should be an integer, and we're going to use a floor on it, right? Or so sometimes when we round, we might use a ceiling where we push it up to the next integer. We might use a floor where we push it down to the next to the previous integer. We might round where we cut it off and basically say, move to the if it's above 5, then go up. If it's below 5, then go down, right? And that's kind of typically what we think about. Here we want to use a floor because we think of someone who is 25 and 3 months as being 25. We think of someone who's 25 and 11 months as being 25, right? So we want to use this month information to round things down. In this case, the only place we get information on months is with infants. So we're going to call those 0. So let's start there. So we're going to do what we've done before, where we're going to mutate in case when. We're going to say age equals case when. Now remember, what case when does is it takes a whole lot of conditions and then transforms the outcome variable that we've named. In this case, we're overwriting age, but it takes a whole bunch of conditions and evaluates those for true and false, and then does the thing on the right-hand side and stores it in whatever variable we've named. So here we're going to take age, and we're going to overwrite it with something that's generated by a bunch of conditionals, right? And that's exactly what we did here. We took race, and we said, when race is equal to this label, African American or Black, just call it African American. When race is equal to this label, call it Asian Pacific Islander, right? Yeah.
I'm not sure if we're seeing what you're pointing to because I didn't see type ages case one and
Can you see me highlighting this right now?
I see you on the shaping script, but I don't see any highlights.
You don't see highlights?
No.
Can you see me typing Tata?
No.
No?
No, you might be on like a different R studio, like
I
on
think
another
you're
platform.
sharing the other screen.
Oh, yay. Oh man, technical competence to the extreme here. Thank you for catching that. That's twice you've saved me today, Sophia. I appreciate it. Now you can see me.
You're starting to share
It's
content.
black now.
Okay, I think we can see you now.
Okay. Okay, that's a relief. Okay. We're good? Okay. Cool. Sorry. Um, so that last 10 minutes of me demoing the script you weren't following along with was really high quality instruction. Um, okay. So, uh, to reiterate, right, here's where we were. This is the race ethnicity categories in the raw data. So I ran all the lines below here up to fix the typos. Now we're going to fix the typos. I'm going to use a mutate and case when to recode race. Right? I'm going to say race, change it, and change it based on these conditions. When the original data says race is this, turn it into this. And what it's going to do is it's going to go through and check each of these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 conditions in sequence. So it's going to start with the first one. If that evaluates to true, then that row of the data gets the assignment on the right-hand side here, African American. But if that equals false, it goes down and evaluates the next condition. If race is equal to Asian Pacific Islander, that row of the data gets assigned Asian Pacific Islander, and then it moves down. This level of actually naming every single condition is not strictly speaking necessary. There's ways to speed this up where you could just make a final condition where I say if true, then make it equal to race, leave it alone, right? Because true always evaluates to true. So if you got through the whole list of conditions and all of them were false, then on the final condition, just leave it alone, right? So that's another kind of approach. In this approach, I went ahead and named all the conditions, and both are fine depending on how much typing you want to do. Okay, but let's move on to what we're after today. So to show you for the first time, because I didn't actually show you the first time, here are all the unique values for age, right? So I use unique to pull out all the values that occur in the data. And maybe I want to arrange it just to kind of make this less crazy to look at. Arrange. Right, character. That's fine. We'll just keep it this way. Okay, so we see a lot of numerics, right? And that's good. But what's going to happen to all of these? What I did last time was I coerced all of these into a numeric vector. I basically said age must be numeric. And so, yes, hi. Here's Dorothy, everyone. Are you going to sit with me for a bit? Is that what we're doing? Okay. Hi, Dorothy's going to join stat.
Hi, Dorothy.
Here, I'll can you hear? Hi. People can still hear me? Thumbs up if you can hear me.
Hey, Dorothy.
Hi, Dorothy. I'm so happy to see you.
Okay, so we can see though, if I coerce this to be numeric, all these things with letters or non-numeric characters on them, like hyphen, slash, months, period, those are all going to turn into NAs. So let's just see what happens if I do unique as dot numeric FE $age. Now I lose a lot, right? Those 11 MON, the 7 MON, 25 to 30, those all got dumped into missing. So I lose information when I do that.
You forgot your mission.
She forgot her mission. She was
I just need to get Mom's phone.
She needed to get Mom's phone.
Yeah. Mom, he had the phone.
You're very stealthy.
She is so sneaky, y'all. Okay. It is hard to concentrate with children in the house. Let me just. I'm sure any of you with kids at home are familiar with what just happened. Okay. So everyone can hear me now that I switched back my mic. Yeah. Okay. Cool. So we lose. So you see those NAs right there. Basically, everything that couldn't be coerced into a numeric cleanly gets turned into missing, and that means we're losing information because we have like a lot of so this 40 to 50. Now I may not know exactly where it is, but it's not 20, it's not 2, right? I know it's in that 40 to 50 range. Um, so what we're going to try and do is recover that information by manipulating the strings into to basically write code that can extract that information. Now, what I could do is manually go through in case when every single one of the values that occurs in the data and make a manual assignment. But we're going to automate some of that. So, as Sophia suggested last time, one thing we can do is we can use a regex, and we can use what's a function called grep to do that. Right now, I'm going to pull grep up in the screen, and just to give you a sense of what grep does, first I'm going to make a vector of strings, and let's call it A, B, C, D, A, and dinosaur. Yep, regular expression. So grep is one way we can use regular expressions to solve problems in R. Grep is also, a function that you can use in lots of different places. So when I say regex, that's just kind of short for regular expression. But we don't have to get that fancy. Yes, here she is again. Are you hanging out with me now? Okay, that's fine. Okay, so Dorothy's going to help us teach stats today. You're not allowed to touch my keyboard. Do you understand?
I'm not touching it.
Okay, thank you. Okay, so we have test, right? So that's what test is. Now let's find a pattern in test. Okay, so Dorothy, do you see what words do we have here?
A, B, C, da.
And what's the last one?
Dinosaur?
For sure.
That's so awesome.
Yeah.
She's great.
Dinosaur.
Because we're going to find the dinosaur. We're going to go on a dinosaur hunt. Okay?
Oh my God, we're finally going at a pace I can understand this class in.
So the first thing I'm going to do, which index is dinosaur at in test? So test has 4 objects in it, or 5 objects in it. Test
The fourth one, fifth
the
one.
5th one, right? So test 5 is dinosaur. So what I'm going to do is I'm going to find the word dinosaur in my string vector. Okay? I'm going to find dinosaur in test, and it's going to return 5. So it's going to tell me the index that matches the pattern that I supplied. Now, if I search for the pattern A, we know saying dinosaur is silly. What's another word you should use?
Dinosaur silly.
Yeah, I agree. Okay, so if we search for the pattern A, so we obviously test 1 is just A. But Dorothy, where else are A's in here? There's an A.
Yeah.
Is there an A there? In number 4?
Yeah.
Is there an A there in number 5?
Uh-huh.
Yeah. So if we do that, we're going to get all the indices 1, 4, and 5 that contain an A. Right? Now, hopefully, we can already see how this is going to be super, super useful. Hey, you gotta chill if we're gonna hang out here, right? It's class. Unless you raise your hand, you don't get to talk. Okay, so grep is super cool. Now,
You.
Mom, I don't want to come out.
I know stats is so fun.
so sometimes you'll see fun colors on the plots I give y'all. That's Dorothy's work. She actually kind of is like enjoying writing code right now, which I'm gonna lean into as much as I can. I mean obviously it's a bit, but what are we gonna do? Okay, so grep returns an index in a vector that so it'll give you basically the rows or the positions in that vector that match your pattern, right? That's super useful. But sometimes I just want to know, like, maybe I don't want to return the list of indices that match. Maybe I want a vector that tells me, does this row match, right? So this gives me a vector of length 3 back because that's how many are there. But if I use grepl, G-R-E-P-L, it's going to give me a true or false for whether that row matches that pattern, whether that row contains that pattern. So now row with A contains true. B does not have an A, so that's false. C does not have an A, so that's false. DA does have an A, so that's true. Dinosaur definitely has an A, so that's true. Now, I'm hoping you can kind of follow where we're going with this, because if I can get a vector of true and false, then that's the perfect thing to use in my case when, right? Because what I want to do is I want to say, does it match some pattern I'm after? If it does, call it this. If it doesn't, then keep on going, right? So this is going to give me a true or false for every row of my vector that we can then use to map on to something else. Now, when we go back to our unique values for age, right? I notice one pattern here with one exception. All of the things that say months are 0. All of the things that say months are less than 1 year old with the exception of 18 months, right? And all the things that say days are also less than 0. Why don't we start with days, because that's uncomplicated. So age equals case when, grepl, days, age, and that's it. And then on the right-hand side, and I'm going to make it 0. And I'm going to keep it character for now, because if I coerce it to integer at this point, it's going to still lose information. I'm going to turn it into a numeric after I've cleaned it. Okay, so, and then I'm going to just basically, I'll show you what we've done so far. I'm going to make the last line T and age so that it'll exit. If I don't make an explicit assignment in case when, it will turn it missing, right? And I don't want to turn it missing, so I'm going to make the last row, just the entire vector is true. So whatever age is at the end, leave it alone, right? And this is a way to cleanly exit a case when without coercing missings. So let's look at what this does. Now let's say unique FE $age. And remember, we had a value for and let's try not to think too hard about however many days old a baby was when they died after an encounter with law enforcement. 3 days, we had a newborn killed in the data. Now 3 days is gone, right? We don't have that anymore. We have 0. And 0 wasn't previously present. Okay, so we've basically taken that 3 days and transformed it into a 0. But that was only one. Now we have all these months, right? And we can see one value where months is not 0, right? So what we could do here, and I think in this case the easiest, we could imagine like a transformation where basically we say, okay, first find the places with months, then take the first word out of that string and tell me whether it's, you know what, maybe, should we go there? Should we go complex or should we do it the easy way? Let's do it. You want to do it the complicated way? Yeah. Okay. So I'm going to have to kind of think through this. So the first thing we're going to do, we need to basically have two conditions, right? First, we want grepl months. Actually, I'm just going to, okay, so the reason I'm going to do MON is because there's no other word that has MON in it in the data, and there are a couple of these MON. Right, so I'm going to use MON because MON is going to exactly match months, but it won't match anything that we don't want. And this is often what you'll do when you're doing something with regular expressions or with other string searches, is you'll take the kind of least common denominator that you can find across the strings you're trying to match and use that. You can also use what's called a wildcard if you're doing regex, where you put an asterisk at the end and it'll match anything that follows or precedes that. But we'll go from here first. We're gonna take mon age, so it has to have months. It has to have MON in it, and word. So here's a new function I'm introducing, the word function, which comes out of stringer, and it extracts words from a sentence. So in this case, all of our ages where there's a word after it have a space following it. So what word is going to do is it's basically going to look for the first collection of characters followed by spaces. right? So it's going to basically treat it as a sentence separated by spaces, and then I can name which word I'd like to pull out of it. So in this case, and word, I want the second word, right? So I'm going to tell it, and the word of age, the second word, I need to start and stop. I'm going to start at the second word and end at the second word. And I want to say, and that word, okay, so we're going to get kind of crazy here, right? We're going to say, and word, I need to convert this into a number, because if this were a general case where I had a bunch of like 18, 17, 16, 15, 12 month, 13 month olds in there, I'd actually need to, what I'm going to do is I'm going to say less than 12, or less than, or yeah, less than 12. So what that's going to do is it's going to take the second word, the first word rather, I'm sorry, not the second word, because the first word is the number. In this case, we're after this 18 months, right? And what we want to get is 18. But we also want to get 6, 9, 7, 2, right? And that's the first word in those sentences. So we want to take the first word out and ask whether it's less than 12. But in order to evaluate whether it's less than 12, first I have to convert it into a number, right? So let's see just what this does first. So I'm going to run that in the console just to show you what this gives us. And it's going to give me a lot of 1 and 0s and NAs, right? Those things that are characters are going to get, if the first thing in it is not a number, some of those with hyphens, right? There's no space in there, so it doesn't know what's a word. Those are going to get axed. But okay, this should work. Let's see. Oh yeah, I need to make an assignment now. If it's less than 12, then make it 0. And if it's, and remember a comma after each condition. If it's greater than or equal to 12, make it 1. Yeah? Everyone following my greater than less than logic on that? If it's less than 12 months, it's 0. If it's greater than 12 months, it's 1. Now, if I had someone's 23-month-old, I might have to get kind of more complicated with this, but I think that'll cover our conditions.
And do you want to then take the age as numeric, like there with the true?
Not yet. You're getting ahead. Oh, right. I need to make these characters. That's the error. Let's try this again. That worked. Okay. So, oh, unique. Okay, so now all those months, right, have been successfully converted into something. They've all been converted into 0 or 1, right? So now we don't have months in there anymore. That's good. Now we have these height. We have a 60s. We have 40 to 50. We have 25 to 30. 46 slash 53. So on these, we kind of need to just like make an arbitrary decision. Now, there are ways to treat these as missing, as partially missing data, and to use. So in general, the principled approach to missing data is to treat it as noise, is to treat it as error, right? Because if we drop cases where we have missing data, we may be overstating how certain we are about things. But in this case, if we treat them as just like completely missing, then we're understating how much information we have, right? 18 to 25 does actually tell us quite a lot. So a principled approach here would be to say, okay, it's between 18 and 25, but I don't know exactly where it is. So what I'm going to do is I'm going to draw random numbers between 18 and 25 and run my models a bunch of times over each of those random numbers, and then incorporate that into my uncertainty, right? That's going to make my intervals, my prediction intervals, a little bit wider. And that's because I'm a little bit more uncertain about where exactly that person is, right? We're going to cover that the second to last week when we do missing data. That's a technique called multiple imputation. And Bayesian models are a really easy way to think about that, because we can effectively treat the data as missing parameters, right? And we can put priors on it. We can do all kinds of things to where we can effectively treat this as another thing that we haven't observed that we can use our MCMC to sample, right? And then that just gets averaged over as part of our uncertainty. So it's a really neat trick. Today, we're going to do what's called a deterministic imputation, right? Where we're going to say it's just one value. I'm not going to, treat this as a random process. I'm going to fix it. And what I'm going to do is I'm just going to put it between the two numbers that were provided, right? So I'm going to just take it as the average. So if someone says 60s, I'm going to call them 65, right? If someone says 30s, I'm going to call them 35 because the numbers they've implicitly given us is somewhere between 30 and 39, right? So let's just put them in the middle. Same thing with this 25 to 30. Okay, let's call them 27 or 28. Now that's not great, but it also means we're not totally throwing away information because that person is more likely to be 28 than they are to be nothing, right? If we drop them entirely, we know they're somewhere. And because we're actually using 5-year age buckets for these models, 25 to 30 is fine because that's how I'm going to classify them anyway. But the 46 to 53, these kind of bump things around a little. Again, the principled way is to basically use this as a source of uncertainty that we can model over. For now, we're just going to kind of hack it and make a call about where things are. So we'll say, and so I can imagine some ways to program this when we have like the 18 to 25 or the 46 to 53 or the 20. But the problem is like then I also have like 20s to 30s, right? So I could use the word function. If you know, word here includes this sep, right? Well, okay. How about this? Oh. No, this is so. If we do an advanced unit with regex, what I could theoretically do is remove all the s's, right? I could basically say find the s's, pull those out, and then first take the s's and then basically add 5 to whatever number that is because a 40s, a midpoint between 40 and 49 is 45. So I could find those s's, add 5 to the base number, and then I could use the word function and change out my sep argument to make it a hyphen or a slash, and then take the two words and take the average of the two words and assign that to be the new thing. So we'll do that, but I have this 20s to 30s. This is going to screw me up, right? Because that's not going to work without more program than it. I'll show you what the basic idea here would be, though. We're just going to throw away that 20s to 30s. That's the only case where it's going to be a bother. So we're going to say, if it's not any of those.
But wouldn't, if you change the 20s to 30s, wouldn't it be changed to 25 to 35 and then you would take the average of that? No.
If I search for.
And
Oh, yeah. Okay.
I feel like it would still
Okay. Let's try it.
work.
See, now you're thinking like a programmer, and it's good. This is the kind of way you got to think about these problems is like, what are the different ways I can go after attacking this? And I think that's right. So if we do our transform the number with an S, it's not going to work exactly because that's one row, right? And so I'd have to like break the words up and then do it. Let's try it. Okay. So if I grepl, are there anything else with S in there at this point? No. Okay. This 20s to 30s is screwing me up. And we're just going to call that person 30 anyway. I'm going to cheat, and I'm going to do age equals because this is just 1, and it's really going to increase the difficulty level of this problem. If it's between 20s and 30s, if it's this value, then I'm just going to assign you to be 30 because that's saying implicitly somewhere between 20 and 39. So I'm just going to call you 30. But then we can do it this way: grepl s in age, and if you find that, then I want you to take the first 2 digits of the character. So I'm going to show you a new function here called str sub. Now, there's also a base R function called sub str substring. This is the tidyverse version of it. So it's going to basically take the first n or middle n characters out of a string. And in this case, anything with S on it, I really just want those first 2, right? We have a couple 100-year-olds in here, but there's no hundreds. So everything is like 40s or 20s to 30s. Well, forget that, but 60s, right? So if I grepl s, then what I want to make the assignment as is substring, or I'm sorry, string sub. Either one would work here. And it takes a string, age, and a start and an end. And that's a start position and an end position. So in this case, I want to start with the first character and end with the second character. So it's going to take those, it's going to pull those first two characters out of the string, but then I want to add 5 to it, right? I want to as.numeric that plus 5. But then my final assignment needs to go back to a character, right? Because it's a character vector and it can't store the numeric in there. So I'm going to as character the as numeric.
Couldn't you just do grepl s and then replace 0 with 5?
Yes. Man, you're kicking my butt here today. It's good. Okay, so what I could do is I know that in all these cases, the second digit is 0, right? So if I do that, okay. Yeah. The grepl s. So I don't know how I can. I'm trying to think of how I can make the replacement here. So ordinarily, what I would do is I would basically have the string sub on the left-hand side and then make an assignment to it. I'm not 100% sure how to do that in this context. I'm certain there's a way to do it. But I'm gonna just do it the way I had it because I know it'll work.
Okay.
No, it's you were right, and it's a smart way to think. But I don't exactly know how to pull it off without some Googling and going on Stack Overflow, which is fine. You know, a lot of these this is not something I spend a ton of time working in, so I spend a lot of time asking for help and looking for help when I'm working on these challenges. But this should solve that. What did I not close? Oh, comma. Missing comma. Oh, it didn't as numeric that first. Okay. And then as character that last. Must be a character vector. Oh, right, 30. 30 is my problem. Okay. Lots of debugging. Okay. Now, the 20s or 30s are gone. Yeah, cool. So those have all been pushed into a 5, right? And if we were to look at the frequency table for ages, we would see those 5 numbers went up. Okay, next are these 2-value ones. So I'm going to basically do a grepl for each I see a hyphen, I see a slash, and I see or, right? So let's do each of those. So let's do a grepl for slash in age, and then we're going to need to do math on these, right? So we're going to take the mean of the, well, so we're going to wrap the whole thing in as.character, right? Because we need to turn it back to a character. I'm going to indent these so that they're a little easier to read, because these get complicated. Good programming syntax is to basically give each function its own line to make it a little more readable. So as character, mean of the first word, but I need to as numeric it. As dot numeric word age 1 with sep. So I need to take, the first, start its first word, end at the first word. And the sep in this case, the separator is going to equal hyphen, right? Minus.
Just one quick question. Can you do the hyphen and the or and the slash in the same line?
I
It
could,
has to be a
yeah.
different one.
So if I use regular expressions, I could. I don't know if I can give it multiple steps in Word. Um, so yeah, the questions you all are raising today are really good and are pushing me up to my limits in terms of how much I know how to do with this stuff off the top of my head. Um, I added an option on the poll for advanced string and regex, and if you want that, vote for that on the poll, and we can cover some of those topics. I'm not prepared to tackle those today just because I haven't reviewed how I would do that. And this is something that I use for like data cleaning, but I don't do a lot with analysis. For anyone thinking about things like natural language processing or doing analysis on social media data, doing like sentiment analysis or doing stuff like that, then you're going to spend a ton of time thinking about these problems, and that's great. And there's a lot of literature on that. I typically work with administrative data and just I'm not thinking about these problems as often. But if it's something that you would like more on, I can do some basic regular expressions and some more advanced string functions in another lab session. But I'm not, yeah. So all that is to say, yeah, there's definitely a way to make or hyphen slash to basically say search for any of these things, and then if you find them, do what I'm about to do. But I'm going to do them one at a time, just because I don't know off the top of my head how to do the fancier thing. So I'm going to take the first word, and we as numeric to that, so we're good. And then I'm going to add that to the second one and take, I guess I could just do a sum. We'll just add it because there's only two. Adds dot numeric, word, age, 1, 1, or I'm sorry, 2, 2, right? Oh, yeah, and sep equals. Okay. So have I closed everything? That closes as numeric. That closes mean. And then I need to close as character. And we can see you get those highlights up here to tell me what's closed. Okay, so that's a lot of function, and it may not work immediately because I might have written something wrong. Oh, still need that comma. If you get that unexpected symbol, that's a comma missing. And it is introduced by coercion. That's probably okay. Let's look at the uniques. Okay. Well, all those hyphens are gone now, right? So that's cool. Let's just double check one, right? So we had like 45 or 49. I'm sorry, this was a hyphen. So we should see a 45 and a 27.5. Well, these are not ordered in any way. That'll be hard to find. Anyway, we'll trust that it's there. We had 101 values last time, 106 now, so those may have gotten compressed down. Ordinarily, I would go through and check to confirm that I didn't just turn them into missing values. I'm not going to do that right now, but that's best practice for sure. I guess what we could do is I'm going to rerun everything. I'm going to do a table FE age before, and let's call this FE2 or FE clean. Okay. And this is it is actually in a bizarre order here. So here, let's look at 45. There's 40 to 50. There's 40s. So 45 prior to doing anything is 497, right? And then after doing this, let's see. So it was 497, and now 45 is 501. So we added cases to that, right? I don't know if that's how many we needed to add exactly, but we did add cases. So some of those didn't just get dropped. Okay. So when you're doing these kinds of recodes, checking your work is absolutely critical because you just want to make sure you're not throwing information away. Okay, so we did hyphen. Now I can just copy and paste this for the next condition. And the next one is going to be a slash, right? But I don't know how many of you have used this feature before, but if I highlight this chunk of code and I hit on a Mac, Command F, on a PC, Control F, if I hit Command F and I do find and replace, in selection, I can change the minus into a slash in all of those cases. 3 occurrences replaced, right? This is a really convenient way when you're renaming variables or you're kind of wanting to adapt a particular chunk of code for something else. It's a really convenient way to modify your code all at once. And then we need to do one more with or, right? So I'm going to do the same thing, highlight the code, change now the slash into or. Oops, I'm sorry, it's minus still. Just make sure the in selection box here is ticked, because otherwise it'll do it for the whole document, which you can always, control D it. Okay, so, and we also have a dot and a slash, right? So let's just say, if you find a dot, if grepl dot in age or, now everyone knows that vertical bar is an or, right? That means if either of these conditions are true, or grepl, there's a little hyphen there in age. I'm looking at this last one and this one, right? Actually, that dot won't hurt us because that can be read as a number. But if either of those is read as a number, then, oh yeah, okay. So actually, Sophia, what you suggested earlier was right, that I can make the assignment based on only those first 2 characters, right? Now we would need to switch it with a 5, and that's the part I didn't quite know how to do. But in this case, I'm going to use string sub to basically say, if you see that dot or that tick, only use the first 2 characters. Drop that last one. Okay. So this is a big, complicated mess of code, right? And this is like, me kind of working through it right now. This is what I could come up with to solve this problem. We are going to get, I did a bunch of math on characters, so we're going to get that warning, but it doesn't turn out to matter for us because we coerced everything to be numeric when we did this that met this condition, and sometimes it didn't work. But I'm not too worried about that right now. Okay, so that's initially what we had, and now here's what we have. And if I as numeric that, I'm fine, right? So at the end of this, I'm going to mutate age equals as numeric age. There's an NA. Yeah, there's some missing values in there. So those are just going to stay missing. They started as missing. They're going to end as missing. Right, see, this is our initial data. And that just means there was no entry in that row when it read it in. So the original data had some missing, and that's just going to stay there. And that I'm going to use, ultimately, what I have done with this data is I've treated those as truly missing and done multiple imputation on those. Okay. Now that mutate age as numeric age will work okay. And now I could do a histogram of it. Right? Where before I couldn't. I'm just going to get an error if I do this, right? X has to be numeric. But now I can look at the age distribution of the deaths in the data, right? And it's very sharply peaked for 20 to 30-year-olds. Okay. I'm certain there are questions. What do you got? So I introduced grepl, I introduced word, and I introduced string sub, right? These are really flexible, really powerful functions that can do a lot of different things. And the kind of use case here was about data cleaning, but there's analytic uses for these as well. But these are, you kind of, the more you add into your kit and the way that, people were talking about solving different kinds of problems using different kinds of tools is exactly, how you're starting to think like a programmer, right? And so the more tools you get in there, the more ways you get to solve different kinds of problems. Okay, so if no one's going to throw a question out, then yeah, go ahead.
I had a question. So, is there, I'm sure there is, I would just have to explore on Stack Overflow, but how could you do all this data cleaning over two like data sets that have not been merged or data frames? Like we have Effie, the fatal encounters, but last time we merged two together. Let's say you wanted to clean.
Yeah.
I guess you probably should merge first and then clean second. I don't know. I was just trying to think. What happens if you have like 1,000 of these, like from differing departments? So
Yeah. So in that case, so in this case, my goal was to merge it with census population data, right? And in the census, those ages are numeric, right? So before I can't merge this at all until I convert the character-based data into numeric data, right? So, but if I know I'm going to be getting, so imagine I'm in a world where I'm like getting data from like 100 different agencies, and they all have different ways of writing up age data, right? Now, what I've just written could be generalized into other data sets, right? So there's no reason if the name of the age variable is always little age, right? Then I could turn this into a function, which we'll cover soon. I could turn this into a user-defined function that's called like clean age, right? And then I could basically say anytime I get a new file, run it through clean age first to make sure that I take up all these common problems that I've seen in age data. Now, what I've written here is almost certainly not adequate to handle every thing I would ever see in age data, right? So we would probably want to think a little more generally about the other kinds of things we would see, and we would see new problems as we go, and we'd have to rewrite the function as we kept going. But yeah, this kind of thing is the sort of thing that I in a lot of projects, I will have a script that's just full of functions that I've written in the past that are useful for cleaning data. Like a common one I hit is there's a numeric index for states called FIPS, and then there's the alphabetical index for states that are the two letters, and then there's the names of the states, right? And so I've written functions that can take, the FIPS codes and turn it into the word, or it can take the FIPS codes and turn it into the letters, or take the letters and turn it into the word, or turn it into the FIPS codes, right? And there's no reason I need to write that out every single time. I could write that as a function that I then call externally, right, from my script, and then use that function to transform the data. So yeah, again, you're thinking like a programmer, right? There's no reason we couldn't generalize this. Now, typically, as analysts, as social scientists, we're not really writing like commercial software that's supposed to solve every problem. We're writing software to solve the problem we have right now, and that should always be your focus, right? Your goal is not to make something that will apply to every situation, because that's not what we do. What we do is we solve our problem to do our data analysis. But yeah, cool. Any other questions? And it's also why, like, okay, yeah, could I imagine a way that would solve this in a more fancy way, but it might take me an hour to think through how to do it? Like, for sure. Could I do that in 5 minutes, with a kind of quicker and maybe uglier hack? Let's do that. Most of the time. Okay, other questions? Again, this is just like first scratching the surface on strings and characters. But and if like string and character analysis is something that you're serious about doing, then I encourage you to maybe move. Like R can do a lot. The T age, yeah, that last condition. Sorry, I'll get to that in one sec. If like string and like web data mining and doing a lot of big data text analysis is where you're going, then R can get you a lot of the way, but you're probably getting into Python territory at that point. But what you've learned here will help you pick up a new language. So the sort of basic mechanics in terms of the theory are similar, but Python is a little more well developed for doing a lot of large analysis of strings. Okay, that last line, the T age, is just an exit condition, right? So Case when is basically, it's going to make an assignment for all the conditions that hit true. And for all those that don't, by the end of the function, it's going to make an NA assignment. And in this case, I don't want an NA assignment. I want it to basically say, if you didn't meet any of these prior conditions, one, if you don't have any of these of the like 10 or 15 conditions I listed out, then just leave yourself alone, right? And what that says is basically, if true is true, after all these other conditions have been evaluated, which true is always true, then assign age to be age, right? That basically says if it doesn't meet any of the prior conditions, then leave it unchanged. Okay, other stuff? Good. So now that's kind of it for what we did here. Oh, and I can imagine now, remember we wrote this big case when to translate all those character-based age intervals into single digits. I maybe if you want some practice, try rewriting this in a way that doesn't need to name every single condition, right? And I think you can probably figure that out with a combination of word and string sub. So you could easily compress this into like 3 or 4 lines of code. Look for, if that word has 1 digit, then it must be either 0 or 1 to 5 or 5 to 9, right? If that first word has more than 2 digits and we're using hyphen as the separator, then take the first one, and if it has a plus in it, then it must be 85, right? And once we've done that, I think you could get it down to 3 lines, at least on the case when. But yeah, so if you want some practice with that, that's the practice. Okay, so I want to move over to the homework solutions. So I'm going to switch over my share window. Sorry, switch over my share window. And hi, everybody. We're going to go to. Am I sharing the right screen? Are you seeing the one with the colored plot? Yeah. Okay. Cool. So I've already loaded in my models because they do take a while to run. One trick for those of you who did this in Markdown, a couple tricks. First, I'm sure you've noticed the RStan output, right? It gives you, if you just like render it in your Markdown, you get all of this, right? And that is ugly as sin. No one wants to see that. So results equals hide. This is a really useful flag option you can put on a code chunk, right? Results equals hide says basically whatever R spits out, do not put it in my Markdown document. It'll still run the code, and you'll still be able to access what's happening in it later in your document, but it will not put anything on the document itself. And if I don't even want to show the code, I can do echo equals F, right? Don't echo it. In this case, I wanted to show my code, but when you're writing when you're writing an actual scholarly paper, you don't want to show your code, right? And the other thing I could do is just go up to the code. If you do a new R Markdown document, you get that initial setup ops chunk set echo equals true. I could set echo equals F, and I could also set results equals hide here, and that'll globally do it for the whole document, right? I don't always want results equals hide because sometimes I'm going to use my code chunks to render output for the screen. But anyway, so message equals F is also nice when I'm doing things that are going to produce warnings, or like when I load my packages, I put message equals F because rethinking and tidyverse both give me a ton of output that I don't want in my document. And so message equals F says, I know you have things to tell me, but please don't tell them to me, right? Another one, message equals F, warning equals F, we'll disable warning. I'll show you more with that when we do our Markdown. Anyway, the other quick trick, especially when we're running these big models that take a few minutes to run, is using a cache, right? So setting cache equals true is basically going to tell our Markdown to take whatever the output of this chunk is and save it in a file. And so every time I rerun it, after I've run it the first time, it's just going to go to that file and pull the results rather than rerunning the code, right? So I'm basically writing the output of that chunk of code onto a file that'll live in the subdirectory for this Markdown file, and then it won't recompile the model, right? So it won't resample the model. It won't recompile it. It won't resample it. It'll just use what we did the first time. And that can be really handy when we have code that takes forever to run. Okay, so let's talk about the homework solutions. Now, I settled on a kind of complicated model, but it's not that complicated. Right here, the challenge for this assignment was really to get you thinking like a data analyst, like a social scientist, right? We know some people survived. We know some people didn't. We have some information about them. So how can I use a regression model to predict who was going to make it and who wasn't? Now, the challenge here was to come up with what's called, some people talked about, maybe you included all of the variables in the model. There's a kind of general principle in social science of parsimony, right? That a less complex model is generally favorable to a more complex model. And this kind of falls into the ideas we have about overfitting, right? So all things being equal, we prefer the less complicated explanation or Occam's razor, right? But if we can fit a model that's less complicated, that has good explanatory power, we don't need to use everything, right? Now, sometimes if our goal is just prediction, it doesn't hurt to throw in even uninformative variables into a model. It might make our models take longer to compile. It might produce errors if things are collinear with each other. I decided not to use the siblings and kids variables, right? Instead, I thought that age, sex, passenger class were enough to work with, right? Now, we could, and as long as you can defend your decisions, you're good, right? There's not a right answer to this problem. There's just, it's a question of whether what you have done is defensible. And we can critique, you present kind of doing, scientific work for peer review. You work through your reason as transparently as you can in the manuscript and explain your logic. And then, run what you've run and defend your choices. And then, it's on your peers to critique your work and then for you to revise it, in response to those critiques. But, so this was kind of an exercise in doing that. Anyway, I thought, the simplest model I could run would be here. Now, did anyone have trouble running these Ulam models? I know I did. I forgot to include my link function a couple times. I forgot to, do all kinds of fun stuff. But, remember to include your link function on the left-hand side when you're running these. In this case, we're running logistic regression, so we need the logit link, the binomial likelihood. So in this case, what I did is I created a new variable called child, because I was working on the assumption that the relationship between age and survival is going to be nonlinear, right? Or at least in part nonlinear. That I expect kids to have a higher likelihood of survival, and then I expect adults to maybe have lower survival probabilities as they get older, but that there's going to be a big jump between kids and not kids. And so what I wanted to do was add in two age variables, one for are you under 18 and one just a linear age term, right? So I'm going to create that child binary variable, right, where it's going to be 1 if you're a child, 2 if you're not. And then I'm just going to turn female into, or sex into, an index. But I'm going to give an intercept for sex and an intercept for child, and then a regular linear slope for age. You could justify using other patterns for modeling age. You could do something similar to what I've done with a polynomial, maybe a second or third order polynomial where you had age plus age squared, or age plus age squared plus age cubed to try and capture the sort of shape where I've got here, this kind of dip in probability around age 18. And a quadratic could probably capture that. There's other ways to do it for sure. Okay. But the final model that I really liked, here's one that includes passenger class, and I'm just going to treat it as a numeric, even though it's not really. It's an ordered category, which we'll talk about ordered categories next week. But for simplicity's sake, I just treated it as if it were numeric. Third class, second class, first class, where first class is the wealthiest. You could have also maybe used the passenger fare, but I thought this was just easier to work with. Yeah, but the model I preferred was here. And for those of you who are looking at all this math and thinking, what the hell is that? Have any of you been able to kind of adapt the LaTeX code, the math code I've been using to write your own equations? I've seen a couple people do it. Um, I'll show you some of this next time, or when we do the advanced R Markdown. Writing math is not too hard. So this is code in a language called LaTeX. LA is spelled latex, but people say it LaTeX. Now it's a whole document rendering thing that is a lot of the guts behind our Markdown. If you wanted to render it in PDF, are using LaTeX, but you can use the what's called math mode in LaTeX anywhere in Markdown, and it lets us write equations in a way that is really pretty. And once you get the hang of it, it's pretty easy to use, right? But things like slash alpha says, well, slash is a special character in LaTeX, and it says there's a command coming, and so slash alpha means go grab me the Greek letter alpha, right? And then, but you'll see like logit renders just the regular words. So anyway, and we'll talk about this more later. Okay, but the model I wanted to run, right, that I thought made sense was to basically interact age and sex with class, right? So basically say that, okay, yeah, I expect age and sex to matter, but I expect first class men to maybe survive more often than third class women, right? I expect the effect of sex and age to differ across passenger classes, is effectively what I'm saying. And to test that, right, I ran a model that just includes model 2, that just includes a linear term for class with no interaction. And then I run another model that includes the interaction term. And then later, I use the compare function to look at which one fits the data better. And the interaction model fits the data much better than the model without the interaction. So here's those models. Now, if you want to use compare, this is briefly touched on in the book, but you have to add this log likelihood equals true argument onto your Ulam fit, because that's how it computes WAIC and the leave one out cross-validation information criteria, is it needs the log likelihood to do that. And you don't get it by default out of RStan unless you say you want it. So make sure to include that argument if you're going to use compare. Okay, so any questions about my rationale? So the rationale for the model, I hope, is relatively clear. Yeah? That I expect that passenger class effect to differ by age and by sex. But fitting it, it's relatively straightforward, right? I need a parameter for each of the interactions, beta 1 times age plus beta 2 sex times p class plus beta 3 child times p class. Questions on the kind of logic on any of that? No? Okay, let's get to the plot then. There are some questions about the plot. So I did a few tricks here to make every possible combination of the things I saw in my data, right? This is sometimes useful for simulating out or generating expected values. In this case, we want to know like what is our expected value of p for each of the different conditions we observe in the data. So I take, okay, so in this case, passenger class is an integer that ranges between 1 and 3, right? So I'm going to make an assignment and have a thing called p class that goes 1, 2, 3. Sex takes on values of 1 and 2. Age, I'm just going to say takes on values between 0 and 99. And I'm going to use this expand grid function. Now, expand grid, what it's going to do is it's going to find every unique combination of the vectors that I provided. And it's going to give that back to me as a data frame. So it's going to give me p class 1, sex 1, age 0 through 99. And then it's going to give me p class 1, sex 2, age 0 through 99, right? If we view, so let's just make simdat equal to this. Show you what that looks like. So expand grid is a super useful function when we're doing posterior inference. So I'm going to view simdat. Right, so first class, sex is female, all the way up to 99, and then it starts on sex equals male all the way up to 99. And then I'm going to go to second class, sex equals male, age 0 to 99. Second class, sex equals female, right? All the way down to the belly of the ship with the third class male 99-year-olds. Not that there actually were any, but we're going to basically take the full range of what I said the data could be and create every unique possible combination. And I'm going to use that to predict, right? I'm going to use that to generate my expected values of P. Because 99-year-olds can't be kids, right? And I need my child variable in there. I don't want to make childs part of this combination, right? I basically still want, only 0 to 17-year-olds to be kids and everyone above 17 to not be a kid. So I'm going to do my if else again. If age is less than 18, you're a kid. If age is greater than or equal to 18, you're not. Then I'm going to use link to apply my link function over semdat, right? So that's going to give me a whole lot of, because semdat is 600 rows long, right? So now I'm going to have 600 vectors of 1,000 predictions. So I've got 60,000 numbers in semdat, or in post P, rather. That's my posterior for P. I'm sorry, so 2,000 by 600. So it gave me 2,000 draws. I thought it only gave me 1,000. Oh, it probably gave me 500 from each chain. I guess that's what it did. That's fine. Now I'm going to do what I've always done, right? I'm going to take my SIMDAT, which has a lot of things I want for plotting, like P class, sex, age, and child, right? Every unique combination of those. And those are going to match exactly onto my apply functions to get the posterior mean and to get the percentile interval. And this is the same thing we've been doing for a while now, right? Does this chunk of code look okay to everybody? Should I walk through that? Look okay? Okay. So now I have my posterior mean and my interval for each scenario. First class, female, 0-year-old, right? Basically guaranteed to survive, right? First class girl infants were virtually guaranteed to survive. Only a for lower bound 4% chance of death, right? Okay. Then I like to make my graphs pretty, right? Because I am particular about these things. So I want to recode the variables to plot them, right? So we turn them into numeric to make it easy for the model to fit. But now that we're done with our math, let's make it pretty, okay? So I'm going to do a case win. So take 1, 2, 3 in P class and turn it into first class, second class, third class, right? And I'm going to take my sex equals 1, sex equals 2, and turn it back into female and male, right? And that's much easier to look at. Then we're going to plot it. I loaded a couple libraries because Dorothy was here and I was working on this and she wanted to make things pretty, as we do. Let's see. Yeah, whatever. Yeah, there's a lot of things you can do to mess with color with our color brewer, and I also like this Viridis package for that, but don't worry about those for now. So let's walk through the ggplot, right? So SIMDAT, obviously, I want my central line here to be PMN, and that's what that looks like. Ooh, right. But I have the Y min and the Y max, and I don't have I don't have the facet in there. So I'm gonna let's remove the ribbon first. A lot of you saw this, right? That's because you didn't facet. So there's actually 2 values at each age for first class, second class, third class. And what it's doing is it's zipping between those values on the plot, right? For each line, it's going up and down at each row. So it's actually drawing out the ribbon for both men and women manually. If I facet it by sex, though, then I get just the line. All I did there was I commented out my ribbon for a second. Okay, but that geom line has an x of age and a y that's equal to the posterior mean, right? For P, the minimum value is going to be the lower bound of the ribbon. The maximum value is going to be the upper bound of the ribbon. Now, because I've turned these into characters, I don't need to do an extra step that maybe some of you ran into problems with. P class is numeric. Let's see what happens if I don't do this part. This is a problem that I suspect many people had. So let's leave the ribbon in and see what happens here. It's going to look weird. Right, aesthetics can't vary with the ribbon. Let's just... Okay. So what's going on with P class now? Before it was discrete colors. Now it's continuous colors. And why is that? Anyone want to guess? Let's look at it just for men, or just for women. I'm going to filter out the men for a sec. Ooh, still funky. I don't know why it's still funky like that. But it is. Because these are still treated as continuous, right? It's going to give me a gradient on the scale rather than discrete buckets. So in this case, to get what I'm after, I need to factor. Oh, it's because I had factor. And so what I need to do is I need to tell ggplot, no, these are not continuous. These are discrete, right? And so I'm going to factor both my color and my fill. And that looks better, but because I have y min and oh, it's because I have min and max in there. Here, let's comment those out and see if my line doesn't look as crazy. No, still does. That wasn't right. I don't know what's going on. But now if I've turned them into factors manually here, so I can do that within the aesthetics. I can do transformations of the variables within the aesthetics, right? So I don't necessarily need to convert it to a factor beforehand. I can do it here, right? So once I turn them into factors, it knows that they're discrete. Now, if I remove those factor calls, let's see what we get. It'll be weird. And I do the full plot. Yeah, okay. I'm getting an error on the ribbon and I'm not quite sure what it is. But make sure when you have a discrete variable, you turn it into discrete. Now, implicitly, I did that, right? So you notice I didn't have factor calls in my final plotting code. And that's because I recoded everything beforehand, right? And I think this is generally a good way to go, is to just go ahead and write some cleaning code before you send things over to ggplot to make the labels consistent with what you want your final plot to look like. So in this case, like 1 and 2 on the top of my facets, right? Like I know 1 is female and 2 is male, but my readers don't. And sure, I could put that in like the caption for my figure, but that's making my reader work, right? And this factor P class over here, that's just ugly, right? And you know, why do they need to know 1, 2, 3 when I could just say first class, second class, third class? So I try, like in the back of your head when you're making plots, you want your reader to have to think as little as possible about what's going on. You want it to be as easy to look at as possible. So now, right, female, male, and class first, second, third. That's pretty easy, right? But there's some other things on this graph that are not fun to look at. P mean, what the hell is that, right? If I don't know this model and I haven't explained it anywhere, that is totally meaningless, right? And even if I have explained it, there's no reason to leave it there. It doesn't have any meaning on its own other than it's attached to something. It's my posterior mean, right? But I can translate that into my outcome, right? And why don't I just say, I'm going to change this. I had it labeled as survival probability, but let's be more honest. It's posterior survival probability, right? Because it's model-based. It's not actual probability. It's what my model says. So there's this cool function called labs, right? And what labs does is it lets me change labels. Now, I could also do, there's a few ways to go after this. You might have seen ylab before, and we could say, hello. And now my plot will say hello on the y-axis, right? And I could do the same thing with xlab, goodbye, to change my x-axis, right? But, and there's also one called ggtitle that I could use. To add a title caption to it. I typically don't do that, and I'll make my figure captions within my document elsewhere. But I'm going to remove all those because labs can do it all, right? So in labs, I can give it label arguments for everything I want. Now, in this case, you note that I get this legend over here, which is good because I want people to know that red is first class, green is second class, blue is third class. But I don't really need that P class label, right? Because it's obvious what this is anyway, right? So I'm going to basically I'm going to rename my x-axis, my y-axis to be posterior survival probability. I'm going to leave age alone because this is what it looks like before the craziness. Age is fine, right? I don't need to mess with that. P mean, I'm going to change that to posterior survival probability. And then I have two more parameters that are getting a label, fill and color, right? Because I had to make color equal to P class to make my line this color, and I had to make fill equal to P class to get my ribbon working, right? So I'm going to make both of those labels into nothing. Here's what happens if I just do it with Y. Then Y will be posterior survival probability now. Now, if I just do it with fill, oh, right. I'm still going to get that P class label, I think. Oh, now it breaks off because now it thinks they have different labels. And that's no good. So I want fill and color both to be equal to blank, which is just going to render nothing there, right? There are other ways to remove titles, but this to me is the easiest. So if I don't want a title on a legend, this is how I'll do it. Find the aesthetic that the legend is mapped to, and in the labels, tell it that the label for that is just nothing. It's just empty quote. And so that'll remove the label there. Maybe there's more I could do to make this attractive. I tend to like theme minimal to retheme things to be, that gray grid people like, but I don't. So if I want to remove the gray grid, I can do a minimal theme. There's also a BW theme, black and white. There's there's a few different, I think what are the other themes? Classic dark. I don't know what dark does. Anyway, that does not look good to me. I usually like dark themes, but not there. Anyway, lots of different themes we could mess with. You can also set these globally at the beginning of your document. I tend to go with theme minimal in most of my work, or theme BW, because the gray background can get a little distracting. If you're going to facet, BW is nice because it puts borders on things, especially if you're going to facet more than two. If you're going to have like a grid, then BW is good because it'll draw boxes. Anyway, that's what I got. Questions about this? No, we're good. Okay.
I was just wondering.
Yeah.
This is kind of I don't know, just something that came into my mind. A lot of the things that you'll see on the web now is like interactive plots. So I'm sure there's a way where you could make it where someone could put their like cursor over, I don't know, third class and see an exact number there. Is that?
Yeah, totally. So I'm going to make a new file called the Shiny Web App.
Mm-hmm.
And we'll just do it in a single, we'll call it demo. So Shiny is R's interactive web language. So if I run this is just a demo. Yeah, I'll save that. Can everyone see this output window? I can change the number of bins in my histogram to dynamically generate different visuals for Old Faithful eruptions, right? That's what this is. Now, this is a really, really simple example, but yes, you can get super complicated with this. This knows HTML and CSS, and anything you can do in R, then you can render dynamically on the web. And this is advanced, but it's totally possible. So if you want to do that, then and you want to do it in R, then Shiny is your friend. There's another language called D3, like the New York Times visual team uses for their statistical visuals that people like a lot. It's a learning, there's a lot of learning to do there. But yeah, Shiny is great and pretty. Once you're already learning R, Shiny is a nice thing to add to it. How useful is that in the social sciences? I mean, I've built a couple Shiny apps. I've never done it for research. So it's a cool thing to learn, especially if you're going to go into, commercial data science where people want to be able to poke around with model visuals, or if you're going to go into journalism or something like that. It's a great tool to learn. For academics, less so, just because we write papers. Typically, we don't make websites. But for policy stuff, it can be really cool too. So yeah, Shiny, it's neat. Base ggplot is not interactive, but we can make interactives pretty easily. Yeah.
I have a question going back to the models. And I'm just wondering I understand that class is an interaction term, but do we not have a prior for it then?
Oh, we do.
Where is it?
Right here. So you'll see that I have an alpha term for so alpha is my sex intercept, right? Men and women have a different baseline probability survival. Gamma is my baseline child intercept. Children and non-children have a baseline survival. But then there's a slope for those. So beta 1 here is the model specification. You can see the pop-up for the equation. Okay, so beta 1 is so there's a single linear slope for age, right? But then beta 2 sex times class is going to say that the intercept for sex is going to jump. I should have maybe called that alpha 2, but it's going to jump based on passenger class. So we're actually going to get 3 intercepts for sex now. We're going to get first class woman, second class woman, third class woman. Or no, we're going to get 5, and then we're going to get men for the other. We're going to have 1 held out, but and then the same for child, right? So the priors then for those, I'm just using a normal 0,2 for alpha and gamma because those are intercepts, and then I'm saying the divergence on those intercepts based on the interactions are going to be normal 0,1.
Okay.
So they're parameters, and they get priors. But so in the model, they're labeled beta 1. The interaction terms are beta 2 and beta 3. And then I'm actually estimating, right, because I'm bracketing it in the notation, I'm actually estimating 2 sex intercepts and 2 child intercepts times class, right? Which is continuous at this point. So I'm sorry, I actually only get 6 more parameters in the model based on that. But yeah.
Okay, thank you.
Yeah. But any parameter in the model gets a prior. And those priors here, I just gave, actually, I narrowed it a bit. I'm sorry, my code. I had some convergence problems, so I narrowed the priors a little bit, and that helped fit the model. I gave them a 0.5 prior instead of the 0.1. Any other questions? Nope. Okay, cool. And were there topics for lab that I didn't have covered in the poll that people want to see? You can also just throw them in the comments on Slack later if you think of something. But I want to